Hello again, welcome back. In this lesson, we're going to go over rational functions. Now, in this video, the most I'm going to do is just introduce some key concepts. We're not going to go into the details just yet, but we're going to get the main concepts so that when we see each other again, we'll be able to go in depth with the bigger concepts. Now, before we go forward, let's review briefly some other functions that we have gone over this year, because we've actually done a lot. All right. Now, the first one we went over, as you may or may not remember, is linear functions. Okay, we did linear functions. Then we did quadratics. Okay, we've done absolute value. We've done exponential. And then what we did last chapter was radical. Okay, so we've slowly but surely been adding to this list of functions, and now we're adding a new one, and this new one is rational functions. Now, you should have a good idea what this word rational means. We've talked about it a little bit, but in case you forgot, rational, whenever you see rational, you can just read fraction, okay, because we're going to be dealing with a lot of fractions. And you got a hint to this in the last video when we dealt with inverse variations of y is equal to k over x. And as you can see, this most definitely is a fraction. But that's it for the intro. Let's go ahead and get started. Now, as I said earlier, this equation is our inverse variation, and now we know it to be properly named as a rational function. This function is quite obviously nonlinear, because as we graphed in the last video, you get two separate distinct curves. Now, this is all important information that you need to make sure you have written down. First and foremost, the parent function of our rational equation is f of x is equal to 1 over x. Now, in this PowerPoint, like I said, all we're going to do is cover our basics, and that means getting very familiar with our parent function. Next, the type of graph is called a hyperbola. I mentioned that in the last video. Hyperbola is just the name of this type of curve. Okay, linear graphs, graph as lines. Quadratic equations, graph as parabolas. And rational functions, graph as hyperbola. Okay? Now, the next big thing is the domain and range. Because as you can kind of tell, the domain and range is now a little bit different. Domain used to be pretty reliably all real numbers. There was a slight exception with the exponential and rational equations, or radical equations, but for the most part, it was all real numbers. Not so anymore. Look at our graph. As you're looking at the picture, notice that there are two spots that the graphs, the lines, or the hyperbola, to be precise, don't cross. You've got this vertical line right here, and then you've got this horizontal line right here. All right, that is not the product of an incomplete picture. Those are boundaries for the hyperbola. No matter how far you go, the lines, the graphs, will not cross these two vertical and horizontal lines. You can stretch back to the beginning of your memory, we learned earlier this year, these lines that the graph approaches and gets really, really close to but doesn't cross, these are called asymptotes. All right, and because the graph doesn't exist, doesn't cross that line, it affects our domain and range. There's a hole there now, and our domain and range will reflect that hole. So another way you could write this is that the domain is equal to, or includes, all the negative values up until 0 at the origin, or at the y-axis to be precise. But then it picks back up again on the other side of 0 and continues on to infinity. Okay, so that U means there's a hole there. That U indicates a hole. There's a value that we don't quite touch, but that the graph picks up and keeps going on the other end. And you can do the same thing with the range. So negative infinity. Again, the hole is at 0, as you can see in the picture. And then it picks back up on the other end. And because the graphs don't actually touch the asymptote, then we use parentheses instead of brackets because the value isn't included. Let's go a little more in depth into this on the next slide. So, what is causing this hole in the graph? So let's start with our equation. Y is equal to 1 over x. This is our parent function. Now, as I look at this, something you should be thinking, something that I am thinking, is that since x is in my denominator, it can't be 0. Okay, because remember there's a rule in fractions that say no matter what, the denominator can't be 0. So in this particular equation, x cannot equal 0. All right, if I were to have a different equation, let's say y is equal to 1 over x minus 3. All right, in this particular equation, x could not equal 3. Because if I were to plug 3 in for x, well, let's see. If I plug 3 in for x, 3 minus 3, oh no, we have a 0 in our denominator. Okay? And so this excluded value is the number or numbers sometimes that would make the denominator 0. And in which case, we can't touch it. It literally doesn't exist there because 0 can't be in our denominator. And this is what causes those holes in the graph. Those are places where we can't touch because for mathematical reasons, it doesn't work. The numbers won't work that way. And it's these excluded values that are excluded from the domain of the function. That's where the holes in our domain come from, is these values. Now these values will change per equation as these two examples illustrate. And so the next question becomes, well, how do we find these asymptotes? Because remember, you have two of them, a vertical one and a horizontal one. So how do we find them? Excellent question. Before we answer it, let's make sure we have our vocab words down. Because as I said, we have two asymptotes. So which one is which? For our parent function, y is equal to 1 over x, I have a vertical asymptote and a horizontal asymptote. Now, the vertical asymptote is going to graph at x is equal to 0. And remember, x equals 0 graphs as this vertical line right here. Okay, the y-axis. All the x values on the y-axis are 0. So that's our line of x equals 0. On the flip side, y is equal to 0 is our horizontal asymptote because all of the numbers on this line are 0. Okay? And so when we're looking for our asymptotes, we're actually looking for two equations, one being x equals, our vertical asymptote, the other being y equals, our horizontal asymptote. All right, and if you didn't know how to spell asymptote or know the exact definition, there it is. I'll let you pause the video in your own time. In the meantime, let's move on. All right, now we come back to the question of how do we find the asymptotes? Well, as with all math equations and concepts, we're going to start with a general equation. So y is equal to a over x minus b plus c. Now, we know for a fact the denominator can't be 0. And so that's the basis for finding our first asymptote. To find the vertical asymptote, we're going to take our denominator of x minus b, and we're going to set it equal to 0, the very thing it can't be. Because whatever this value is, that's where the asymptote is. And as you can see, it's very easy adding b to both sides. X is equal to b. So your vertical asymptote is going to be whatever b is right now. Okay? Or wherever the denominator equals 0. For our horizontal asymptotes, those are a little bit easier. Our horizontal asymptotes, y, is going to equal whatever c is. Okay, so whatever c is, And again, C is this value right here. Whatever that number is, that's going to be our horizontal asymptote. So when you go to graph these things, it's a very good strategy to find the asymptotes first. That way you have a general idea of where things are. Okay, let's practice that on the next slide. And here we go. Now, for this PowerPoint, we're not going to graph in detail the individual points. As I said, all we're doing in this PowerPoint is covering the basics. So we're going to find our two asymptotes, and then we'll pick up in class with the graphing of the individual points. But for now, let's find our asymptotes. So our vertical asymptote is going to be the x equals. So vertical asymptote. And to find the vertical asymptote, I'm going to take my denominator, which in this case conveniently just is x, and I'm going to set it equal to 0. And that, quite literally, is my vertical asymptote. So I'm going to change colors. I'm going to take this, and I'm going to graph x is equal to 0 right here on the y-axis, which is exactly where x is equal to 0. Then I'm going to do my horizontal asymptote. And remember, the horizontal asymptote is y is equal to c, or this back value. So I have y is equal to a -4. I'm going to graph that. So down 1, 2, 3, 4. That line right there. So those are my two asymptotes, which means that my hyperbola are going to be in those quadrants. Where in the quadrants? Well, if you remember from last PowerPoint, we talked about if k was positive, what it would look like. All right, if k is positive, it's going to give us an equation that looks kind of, or a hyperbola that looks kind of like this. And then if k is negative, the hyperbola is going to look like this. Ish, heavy on the ish. When I look at my graph, or my equation, I see that k here is very much positive. So my general sketch of this graph is going to be something along this line. Okay, and again, this is just a rough sketch to kind of show you what's going on. We'll graph the individual points tomorrow, or next time I see you, whenever that is. And there you have it. That is a general sketch of these hyperbola with the asymptotes being drawn and being correctly labeled. We'll pick back up here next time. For now, that's all I got for you. If you have any questions, make sure you mark them. Otherwise, I'll see you next time.